Okay, this is screencast number 4 for Physics 101, Professor Morrison's class. The assignment was to find the coefficient of friction between the car's tires sliding on the ice and a man's sneakers sliding on the ice. The first one I did was the car sliding on the ice. I drew a free body diagram of the car and showed the forces, the one going to the right being the force of friction, which could be substituted as UKN, normal friction going up, and weight coming down, which could also be substituted by meters times gravity, gravity being a constant of 9.8 meters per second. What we didn't know was the acceleration in the x direction and the coefficient of kinetic friction. What we did know was the gravity. Through the video we were able to find the distance of x, which in the x direction, which was 8 meters, the final velocity, which was 0, the mass of the car, which was 1,353, and the time by taking the final and initial frames and dividing them by 30 to convert the frames per second to 3.03 seconds. We also know that acceleration in the y direction, as the car does not move up or down, is 0. Drawing out the sigma of force in the y direction equaling out to mass times acceleration in the y, we know that acceleration in the y direction is 0, canceling all of this out. We carry the weight over, and normal force will equal weight, or normal force equals mass times gravity. In the x direction, however, the m's would cancel each other out, leaving us with a negative coefficient of kinetic equaling to acceleration in the x direction. Carry the gravity and a negative over to the other side, and we get that the coefficient of k equals a negative acceleration in the x direction divided by g. By taking the distance, the change in distance and time, we were able to find the acceleration in the x direction being 2.64 meters. Because of that, we're able to plug it into the rest of the formula and find the coefficient of k for the car sliding. Of course, we did the same thing to find the guy sliding on the ice as well. First, I did a free body diagram, decided which coordinate directions would be the positive for the x and the y directions, listed what I knew, which was almost exactly the same as what we knew for the car, and what we didn't know. The same process was used to eliminate and find that ax was equal to 3.129289, and the coefficient of k was the acceleration in the x direction, which was 3.1289, divided by 9.8, leaving us with a negative 0.31927.